Hello, my name is Amar and I'm going to present our work, MixVPR, feature mixing for visual place recognition. We introduce a new all-MLP aggregation technique, which is faster, robust, and more efficient than existing methods. It does not employ pyramidal or local feature aggregation, and it achieves the best results on 5 large-scale benchmarks. The process of recognizing a place can be summarized as follows. Given a reference database, we use a neural network that is trained for place recognition and generate a descriptor for each image and keep it as reference. This is usually done offline before the system is deployed. Then, given a query image, we use the trained neural network to generate a descriptor, then use KNN to retrieve its most similar ones from the references, and column match. There are a lot of challenges to this problem. What we see in this example are two different places, but they have a lot of common visual cues, which may mislead the recognition process. There are changes in viewpoint and camera position. The appearance of a location can vary significantly due to weather and seasonal changes, and also illumination and day-night lights. Deep networks for visual place recognition are usually composed of a backbone and an aggregation layer. The backbone is most of the time a cropped CNN network. The aggregator takes the CNN outputs and aggregates features into one compact descriptor. An example of an aggregation layer is the average pooling, or the generalized mean pooling, which is most used in image retrieval. And more importantly, NetVLAD, which is the most used technique for place recognition. In this work, we are introducing a new technique that we call MixVPR. We take feature maps from an intermediate layer of CNN, then we individually flatten each of them and feed it to a cascade of feature mixers. Feature mixer replaces pyramidal and local feature aggregation thanks to its full receptive field, where each neuron has a glimpse into the entire feature map. After feature mixing, we apply depth-wise projection to reduce the dimensionality of the channel dimension. Then, apply row-wise projection to reduce the dimensionality of each feature map. Finally, we flatten and normalize the output descriptor. We compare our technique to the state-of-the-art and obtain best result with big margins, especially on the challenging Nordland benchmark, where we outperform the best existing technique by 24 points of recall at 1. Our technique is efficient and requires at most half the number of parameters compared to existing techniques because we are cropping the backbone CNN at the middle. In an ablation study, we show the importance of feature mixing. We see that introducing only one feature mixer improves recall at 1 by 1.8 points on Pittsburgh and 4 points on MapillarySLS. We also compare against two-stage retrieval techniques that employ re-ranking, which is known to increase recall at N performance at the expense of heavy computation and memory overhead. Although our technique does not perform any re-ranking, it achieves better performance all while being at least 500 times faster than TransVPR. In these examples, we show the robustness of our technique for multiple challenging scenarios. As a conclusion, we think that MLPs, or multi-level perceptrons, are all you need to aggregate deep features for visual place recognition.